Slope measures the steepness of a line. So slope measures the steepness of a line. Slope measures how steep a line is, right? If you're riding your bike up a really steep hill, you're going to have to do a lot of work. But if you're riding your bike up a not very steep hill, a less steep hill, it requires less work, right? Just like if you're riding your bike down a steep hill, you have to be a little careful that you don't go out of control. Or it's an easy cruise, right? Steepness is the intensity of the hill, whether it's going up or whether it's going down. So slope can be positive or negative. Slope can be positive, meaning it goes up, right? You're going to have to ride your bike up a lot. Or it can be negative, meaning you're just going to coast. Slope can be an improper fraction. You go up 4 and over 3. You go up 7 and over 2. Right? Slope, the measure of the steepness, can be positive, it can be negative, it can be an improper fraction, it can be a whole number. It can be 0 or impossible. And this impossible has a specific word. It can't be a decimal. And it can't be a mixed number. All right, so let's look at Mr. Slope. Let's look at Mr. Slope. So here's Mr. Slope's face, right? A positive slope goes up from left to right, right? If you are reading, right, left to right, a positive slope goes up from left to right. A negative slope goes down from left to right. So a positive slope increases on the right side. A negative slope decreases on the right side. A slope of 0 is flat. This has 0 slope on it. Its horizontal line has 0 slope. A undefined or impossible slope, undefined, is vertical. So I think about it truly as riding your bike along these hills and the amount of work it takes. So if I'm riding my bike, this takes positive work. I have to put in effort. If I'm riding my bike, it takes negative work, right? It does the work for me. If I'm riding my bike, and maybe this isn't necessarily work, this is like zero fun, right? And then if I'm riding my bike, this is impossible. It's undefined. You cannot do it. You can't. Don't tell me if you cannot ride your bike down a completely vertical hill. No. I'm not listening to you. I hear this every year. I'm telling you, you can't. You know it too. So we're going to put that this impossible is technically called undefined. Impossible slopes, it does not exist, it can't happen, is undefined. So you have four options for generic slope. Either it's positive, it's negative, it's zero, or it's undefined. But then you can get into specifics, right? So the generic stuff is that positive, negative, zero, or undefined. That's generic. Then I can actually calculate slope. So if you're looking at slope, if you're talking about slope, or when we were doing constant of proportionality back here, how did you figure out the steepness of the line, or from one point to the next? What did you do? How did you figure out the constant of proportionality? Remember, it says it could be an improper fraction. It's not a mixed number. How did we figure out the constant of proportionality? You just did it on your quiz. I know you know how to do it. How do you figure out, if you have a graph or you had a table, how did you figure out the constant of proportionality? How much it changed each time? Simplified. That is not how you found it out. You simplified the fraction maybe that you found. But how did you find the constant of proportionality? Brooke?
You saw how many numbers were in between the x values and the y values.
You found the change in y over the change in x, correct? Is that what it says right there? Change in y over change in x? Is that what I'm pointing at? And then you went over here and you looked, the change in y from 0 to 20 is what? From 0 to 20, what's the change?
20.
And from 0 to 2, what was the change?
2.
So 20 over 2. And then Brad said you simplified. What is 20 over 2? 10 over 1. And 10 over 1 is really what? 10. The change in y over change in x. So that's what we're going to do from slope from a graph. Because you guys, slope is the constant of proportionality. It's the change in y over change in x. Slope and constant of proportionality are the same thing, with one difference. Oh, that's a long word. Slope is constant of proportionality, with one difference. Constant of proportionality had to go through the origin. Slope does not. Constant of proportionality had to go through the origin. Slope does not. And again, how did you find the constant of proportionality? How did you find the constant of proportionality? Change in y over change in x. Slope is change in y over change in x. Change in y over change in x. Which way is the change in y? Can you show me with your arms or your hands? Which way would the change in y go? Where is the y-axis? Which way does the y-axis go? Vertically, up and down, correct? Which way does the change in x go? If the change in y is the vertical change, what's the change in x? Horizontal change. Sometimes the formula for slope is shown as rise over run. Rise over run. Because rise means to go up for vertical, and the run of a graph is the horizontal. Vertical over horizontal. Rise over run. Is this a fraction? What's in the numerator? The y value, the change in y. What's in the denominator? The x value, the change in x value. So here's how you do this. You're going to follow these steps. Step number 1. Starting at the bottom ordered pair. Starting at the bottom ordered pair. Count up, and we're going to put in until parallel with the top ordered pair. Starting at the bottom ordered pair, you're going to count up until you're parallel with the top ordered pair. What does parallel mean? Side by side. And since you're counting up, right? Starting at the bottom ordered pair, count up until parallel with the top ordered pair. So counting up, what does that represent? Counting up the y. So this is going to be your numerator. This is the numerator value. Then you're going to turn the corner and count over to the top ordered pair. So the directions, you're starting at the bottom ordered pair and you're counting up. And you're going to stop counting up when you're even or parallel with the top ordered pair. So you're going to start at the bottom and count up. 1, 2, 3, 4, however many. You're going to stop when you're parallel with the top ordered pair. That number that you just counted up is your numerator because it was the y. It was vertical. You're going to turn the corner now and count over to the top ordered pair. When you're counting over, what's that signify? The x, because over is horizontal. This is your denominator. That's your denominator value. And step 3 is to simplify. Step 3 is to simplify. When you simplify, what are okay answers? Whole numbers are great. Improper fractions are great. What can you not have?
Mixed numbers.
Mixed numbers or
0.
you can't have 0. You can't have a decimal. All right, so we're going to glue this into the next page in a minute. I want to see my directions while I'm doing this. All right, so step number 1. Look at direction number 1. What does it say? Step number 1. Start at the bottom ordered pair, count up until parallel with the top. All right, I'm going to zoom way in so you can see it. Look at number 1. Put your pencil or pen on the bottom ordered pair. And we are going to count up until we are parallel with the top ordered pair. 1, 2, 3, 4, 5. And I'm going to stop there because I'm parallel, correct? So 5. Step 1, whoa. Starting at the bottom ordered pair, count up until parallel with the top ordered pair. That's your numerator value. I'm done with step 1. What's step 2? Turn the corner and count over. So how many do I go over? 1. So that's my denominator. And now we're going to simplify. 5 over 1 simplifies to 5. And if we look at Mr. Slope, does that, here's a positive line, right? It goes up to the right, and this is up to the right, so it's positive. I'm good to go. Yes? Let's try the next one. Find the bottom ordered pair. And you're going to count up until you're parallel with the top ordered pair. 1, 2, 3, 4. Agree? Yeah. Over. And where do you go now? How many did I go over?
2.
I went 2, but I didn't go forward 2. I went backward 2, so what kind of 2 should it be? -2. And 4 over -2 simplifies to what? -2. All right, let's try 3. Start at the bottom dot and count up. What kind of shape are we making? We're making a triangle. You should have a triangle, right? Remember doing this for distance formula when we did Pythagorean theorem? You drew a triangle. How many do you go up? 2. How many do you go over? Nope. Whoa. Count. You're counting the spaces. 1, 2, 3, 4, 5. Can you simplify this? No. Is it true that this represents a positive slope? If you're riding your bike, you're going to have to put in some work to get there. Okay. Number 4, let's count the slope. Start at the bottom dot. How many do you go up?
0.
How many do you go up? 1. How many do you have to go over? 0. Ladies and gentlemen, I still remember this from when I was in elementary school. It's okay for 0 to be on top of a fraction. But no way can 0 be on the denominator of a fraction. If you have 0 in the denominator, it does not exist. This is a vertical line. What is this called? It's impossible. It's undefined. It does not exist. Number 5, count your slope. Start at the bottom dot. Draw your triangle. Count vertical and horizontal. Rise, over, run. Vertical change was 5. Do you agree? Horizontal change, 1, 2, 3, 4. Do you agree? Can I simplify 5 over 4? It's as simple as it gets. We do not want mixed numbers. We do not want decimals. So this is my answer. Is it positive? Yes.
Positive.
Number 6, start at the bottom dot.
0.
Which one's the bottom dot?
I don't know.
We don't know. So how many do you have to go up?
0.
0. And how many do you have to go over?
1.
Can 0 be on top? Simplify 0 out of 1. 0 out of 1 is 0. All right, glue this on page 28.